Good morning to one and all present here. I am Sayyida Nazmeen and it's give me huge pleasure to extend you a very warm welcome to on behalf. स्टार्ट करना है क्या सर?
स्टार्ट करो स्टार्ट
Okay. Good morning. I am Sayyida Nazmeen. It's give me huge pleasure to extend you a very warm welcome on behalf of our college, MSP Mandals, Yashwantrao Chauhan Mahavidyalaya, Bejogai, who collab all of us for national seminar organized by Department of Mathematics on the topic Indian mathematician and their contributions. It is rightly said, science is nothing but a way of thinking, much more than it is a body of language. And like Carl Friedrich said, mathematics is the queen of science. It gives me pleasure and pride to welcome and introduce our guest. We are extremely honored to have our keynote speaker of today's program, Professor Dr. Uday Shankar Chakraborty sir, and resource person of today's program, Professor Dr. Charudat Bele sir. And chairperson of today's program, respected principal of our college, Dr. Shivdas Sirsat sir, and vice principal of our college, Dr. Ramesh Shinde sir. May I request everyone to give them a warm welcome. Now, I would like to request our respected principal sir, Dr. Shivdas Sirsat sir, to give us some guidance.
Good morning, everybody. MSP Mandals, Yashwantrao Chauhan College, Ambejogai, District Bids, Department of Mathematics organized one-day national level online seminar on Indian mathematicians and their contributions. I am grateful to all Honorable Executive Council and CDC members. The office bearers of all the organization have given their best wishes for this seminar. Today, our guest of honor and keynote address of this seminar, Honorable Dr. Uday Chakraborty, Professor, Department of Mathematics, Assam University, Silchar, Assam. Other resource persons, Honorable Dr. Charudatta Bele, Associate Professor and Research Supervisor, Sri Shivaji College, Parbani, Maharashtra. Convener of this seminar, Ms. Sayyeda Nazmin, and organizing committee members, Vice Principal Dr. Ramesh Shinde and PK Jadhav, technical supporter Mr. Ali Sheikh and Mr. Asif Sheikh, my all teaching and non-teaching staff members. I have an immense pleasure to organize these events for the benefit of new biddings, scientists and research scholars, faculties. Dear participant, today I am going to talk about a very important and exciting topic, Indian mathematicians and their contributions. It is a great honor for me to chair of this one-day online national seminar. We have gathered here today not just to discuss formulas and theorems, but to celebrate a culture that has seen the universe through the lens of numbers for thousands of years. Today's seminar is a reminder that while the world often looks to the West for the origin of modern science, there has always been a strong Indian rhythm in vibration of global mathematics. Indian mathematics was not merely about calculations; it was about philosophy and pursuit of universal truth. From the precious of subjects like the architecture of the Surpa Sutras to the profound abstract concept of the modern era. Our mathematicians have transformed a paradigm of human thought. The concept of zero was discovered Aryabhat. He demonstrated the use and importance of zero in mathematics. The world. We just remember that without the Indian concept of zero and the decimal place value system, the digital revolution we live in today would have been mathematically impossible. Brahma Brahmagupta primarily discovered the mathematical rules for zero and negative numbers. In his three sides, Brahma's put Siddhanta. He recognized zero as an independent member, independent number, and made significant contribution to algebra. Bhaskaracharya, second Bhaskaracharya wrote the loop Siddhant Shiromani and made great contribution of mathematics and astronomy. Madhav made extremely important contribution to mathematics and astronomy. He is considered the founder of the Kerala School of Mathematics. Today's discussion will ignite the spark among the researchers, teachers, students, and will provide researchers with new perspective. Lastly, I appeal to the participants to be online throughout these events and take the benefit of all deliberations from expert. I hope that there will be fruitful discussion in this seminar. Once, thank you once again to all participants.
Thank you so much, sir. As we all know, this seminar highlights some renowned Indian mathematicians and explain their importance contribution to the field of mathematics. It's really proud and honor for our college to organize such a beautiful program with such amazing guests. Words are too short to describe their achievements. Now I request to my colleague Poonam Lakhe Madam to introduce our today's keynote speaker, honorable and respected guest, Professor Dr. Chakraborty sir. Good
Good
morning,
morning, everyone.
may
May
I
I
audible
audible?
to everyone?
Respected chairperson, distinguished guests and teachers, and all the students. Good morning, first of all. It is my great honor and privilege to introduce Professor Dr. Uday Shankar Chakrabarti sir, a distinguished academician and an eminent mathematician from the Assam University, Sikar. Professor Chakrabarti sir is currently serving as a professor in the Department of Mathematics at the Assam University. His academic journey reflects excellence, dedication, and sustained contribution to higher education and research. He completed his PhD in mathematics in 2010 from the Assam University. Even during his early academic career, he demonstrated exceptional merit by qualifying CSIR UGC NET with Junior Research Fellowship and GATE with an All India rank of 178. He secured first class first position with a gold medal in his MSc in math. Sir has a rich teaching experience of nearly two decades. He began his teaching career as a guest lecturer at the SS College, Halikandi, and subsequently served as the lecturer and assistant professor. His research interacts in advanced areas of mathematics, particularly functional analysis, geometry, Banach spaces, and non-communicative algebra. He has published several influential research papers in renowned journals such as Advances in Operator Theory. Professor Chakravarti sir is also an experiential research supervisor. He has successfully guided the PhD scholars contributing to the development of young researchers in the mathematics. His mentorship emphasizes strong fundamental research ethics and independent things. Professor Chakrabarti sir is respected teaching profile researcher and committed academic leader whose contributions have significantly enriched the field of mathematics. His academic journey is truly inspiring for all students and researchers. It is indeed a privilege for us to have such eminent scholar among us today. Please join me warm welcoming Professor Uday Shankar Chakrabarti sir. Please sir.
To know the more about today's topic organized by our college and Department of Mathematics, I'd like to request Professor Dr. Chakraborty sir to deliver his speech on the topic Life and Work of Madhava, a Great Mathematician.
Yeah, thank you, madam. Am I audible?
Yes, sir.
Okay, thank you. So, first of all, I would like to thank the organizers for kindly inviting me in this seminar. So, without further ado, let me share my screen. Yeah, just a minute. Let me share. Yeah, is my screen visible?
Yes, sir.
Okay. So, respected chairperson of today's program, respected organizing committee members, other resource persons, and dear participants. So first of all, let me say one thing that I am not an expert in this area at ICT, this IKS. But when I have been approached by the organizing committee, I thought that this is a nice platform to say something about the life and work of Madhava, whom I respect a lot. And he is considered as the founder of calculus, the inventor of calculus in India. So let me begin. Yeah. So the first mention of Madhava was in the year 1832. The first external reference I can say to this Kerala School of Mathematics was by Charles Wish in 1832. And this was published in the Royal Asiatic Society, London. And this fellow, Charles Wish, he was a British, and he talked about the Kerala School of Mathematics. But after that, there was a long gap. Till the mid-20th century, probably in 1960s, there was no mention of Madhava in European and American writings. His name appears in print probably in 1940 and in connection with a book that is called Yukti Bhasha, written in Malayalam. And before I proceed further, let me say one thing, that why I have chosen this, because I got inspired, I got motivated by reading a book written by Professor P.P. Divakaran. He wrote a very nice book on Indian mathematics. I'll show in the references. And he has given lectures in ICTS also regarding Madhava and this Kerala School of Mathematics. So whatever I'll say, most of the references I have taken from his books and his writings. Yeah. So after that, K. Kannujuni Raja and K.V. Sharma, they studied the works of Kerala School of Mathematics, but mainly astronomy, not mathematics. And in their work, Parmeshwara received more attention than Madhava. Then Saraswati Amma in 1950 in her thesis and 1979 in the book, she presented Madhava's theorems with proofs. Also, C.T. Rajagopal, he emphasized algebraic and analytic aspects of the work done in Kerala School of Mathematics. So the attribution of the key Kerala school ideas to Madhava is not secure. A unified method is recognized. What he did actually, uh, they give a unified method to infinitesimal calculus. It was not discrete calculus, rather the modern calculus that we study. That was invented in Kerala School of Mathematics. And it was David Mumford in 2010. He compared Madhava with Newton and Leibniz, who are considered as the founder of calculus. So these are the sources of Madhava lineage. Madhava and Parameshwara, they are almost contemporary. The Madhava was born in 1350 and up till he was active till 1420 to 30. It's not fully known. Parameshwara 1360 to 1450. And then there are disciples like Damodara, Nilkantha, Somyaji, Jeshtadeva, Shankara, and Achyuta. They have also contributed a lot in Kerala School of Mathematics. Now, these are the key texts where from actually we came to know regarding the works done by the scholars in Kerala School of Mathematics. And the key text is definitely this Yukti Bhasha. It was a Malayalam prose where the complete proofs of the major results given by the scholars were mentioned. And then this Aryabhata Bhashya, explicit reference to Madhava was given. And the results attributed to Madhava are taken to be genuinely his. These are not just a reframing of ideas of other mathematicians, but these were genuinely the new ideas invented by those scholars. Now, what is this Neela school? So, the Kerala School of Mathematics, what is called Kerala School of Mathematics, that is probably best described by this Neela school. Now, we not only know the line of succession of these 6 or 7 generations of Madhava's brilliant descendants, but also where they lived and worked in a cluster of what P.P. Divakaran mentioned, that he prefers the term the Neela school, not as Kerala School of Mathematics, because this level Kerala school is historically and geographically misleading. There was another school of astronomy elsewhere in Kerala in 500 years earlier. So if we say Kerala school, probably there will be a confusion regarding the school where Madhava worked, means the institute where the Madhava works and where the main discovery of astronomy took place. They are different. So it is always better if we say this Neela school. Now, what is this? This Nila is a river. So in the lower basin of the river, now that is called Bharata, but the classical name of that river was Nila, not Nila. So Nila. Yeah. So it is nowadays we know that what are the key things where Madhava and his contemporaries and disciples worked on. Mainly the infinite series for pi, and then trigonometric sine and cosine series, this arctan series. Their works not only limited to these, they worked on area and volume of the sphere, and their central ideas lies on the calculus on the circle. Now, Aryabhatta also worked on calculus, but his calculus was discrete calculus. So, what is the basic difference between this discrete calculus with the calculus invented by Madhava? Is that this Madhava's calculus was not discrete because the functional differences is proportional to increments, iterated differences and summation. And Madhava actually first said that this infinitesimal increment, he took the increment tends to 0. Yeah. So divide as finely as you please, and the division tends to infinity. And they could solve the differential equation like d2 dx2 sin x equal to minus sin x. Integral formulation using the fundamental theorem, the recursive iteration, which is given by the samskara, and the derivation of sine and cosine power series that already I have mentioned. All these are the major works done in Kerala school. Yeah. Now, if we compare with Newton's work, Newton used binomial series and inversion, whereas the Madhava's approach is direct and conceptually unified. He gave emphasis on limits and convergence of sequences. Some other calculus problems that he took was rectification of arcs and computation of pi, surface area of the sphere, volume of the sphere, etc. Now, the local linearization via the division of infinity, these are the things which we can say the birthmarks of calculus that was done in Nehru school. This infinitesimal as limits of sequences. We know this modern definition of limit, where if we have a function f defined from some interval of r to r, and if we want to define the limit of that function at a point, let's say x naught, then what do we do? Basically, we mean when x approaches to x naught, f of x approaches to some fixed real number L. So for that, our method is we take the infinitesimal distance and we take as fine distance as possible. That is the definition. That is the main theme of calculus. So what Madhava did, he took infinitesimals as limits of sequences. And that is very much modern. And discrete integration by parts. That also a contribution to that school. So the question is it calculus or is it something like pre-calculus that is definitely that was before Newton and Leibniz. But can we say that whatever they discovered was calculus? The answer is yes. That is not merely pre-calculus or anticipation. That was genuinely calculus. Clear contrast with Greek exhaustion method. His approach was direct, as I have mentioned. And it was a complete and general new paradigm. So what are the key things that they used? This infinite sequences and limits, convergence of infinite series, formal inductive reasoning. Now, beyond calculus also, they contributed a lot, like the abstract notion of function, they worked on it, algebra of polynomials and rational functions, this rapidly convergent series and remainder estimates of pi. These are some of the key things that they did. Now, this is the basic question. Who was Madhava? Where was he from? So he was from Sangamagram, identified with Kudalur of the Alanjipalli house. And as Professor Divakaran mentioned, that probably he was a migrant lineage from Tulunad. So these are some historical context. The transmission of Bhaskara II's ideas to Kerala and Madhava as a transformative figure, a brilliant lineage lasting until the early 17th century. Now, the legacy of Madhava. All this brilliant work done by Madhava and his teammates, all these are rediscovered only in the 20th century. So this is quite new. Still a lot of things are to be tested, are to be discovered, are to be seen. And the major chapter in the global history of mathematics is definitely this Nehru School. But the problem is little contemporary impact outside his circle. That is the major problem. So Madhava developed a full-fledged infinitesimal calculus. That calculus, his calculus was grounded in geometry, limits, and infinity. And undoubtedly, he was one of the great original mathematicians. And we can say that calculus was born in India, in Nila school, by Madhava, his co-workers, and his contemporary mathematicians. Now, these are the references, key references, where from I have taken all the information. There are lots of references if one can search in Google, he or she can find. But these are some key texts. The first one is a book written by P.P. Divakaran, The Mathematics of India, Concepts, Methods, Connections. It is published by the Hindustan Book Agency and outside India by Springer in 2018. So this is an excellent book. You will not only get the information regarding Madhava, but you will get a lot of information regarding other brilliant mathematicians of India and their contributions to mathematics. Professor Divakaran gave a series of lectures rather, in ICTS in 2020. So that is also available online freely. One can go through. The title is The Men Who Invented Calculus, The Life and Work of Madhava. And all his lectures are recorded and uploaded in YouTube. So interested students can go through this ICT lecture series 2020. So, and I have given the link also. So if you follow this link, you will find a series of lectures given by Professor Divakaran. And a lot of information you will get. So I would like to say something that Professor Divakaran has mentioned in his book and in his lecture also. So what he says the title of his slide is The Ocean of True and False Knowledge. So what actually he says that in these days of make-believe history, I have to add a footnote. What I have described is what is in the technical writings, not in the imaginative literature of Itihas or Puran. I have tried to be as faithful as I can, adding nothing to my own and distorting nothing. What comes out of it all is that there is a typically Indian style of doing maths and an unbroken thematic continuity, whether done in Bihar or in Kerala. And what nourished this pan-Indian activity is its best, is the ready acceptance of fresh stimuli from time to time. The story of Kerala maths, as that of the Aryabhatian revolution, is a wonderful case for how a culture needs to be open, even if that won't produce a Madhava every century. Kerala was never a part of a kingdom or empire based outside of itself. That didn't stop people from banks of Ganga, one can say the infiltrators, from ending up there in large numbers, bringing their talents with them, never mind who ruled which part of the lands, and they had to traverse. So these are the words of Professor Divakaran. We have to take this seriously, that whatever Madhava has done, all are available in the text. The proofs are given. These are concrete history of mathematics. These are not just imagination. So we should not mix imagination with the scientific discoveries. And before I end, this is some information for the students. So after the name of Madhava, there is a competition of mathematics. So organized by the Bhaskaracharya Pratishthan, Pune, and funded by NBHM, National Board for Higher Mathematics. The name of the competition is Madhava Mathematics Competition. This is for the undergraduate students. A student who is pursuing BSc in mathematics or BTech, BE, engineering students are also eligible to appear for this exam. And of any semester, only the undergraduate students are eligible. And every year the exam is held in the second Sunday of January, normally. So this year the exam was held in 11th January, Sunday, almost throughout India. But the main center is, of course, the Bhaskaracharya Pratishthan, Pune. So students can take the benefit of this. They can appear and they can see. And the information is available in the website, as I mentioned, www.themadhavacompetition.in. So this is all about what I wanted to say. Thank you.
Thank you so much, sir, for your information and valuable guidance. It will be very beneficial for all of our students and we also. Thank you once again, sir.
Yeah, thank you so much.
Now, I again request to Lakhi Madam to introduce our next speaker, Dr. Charudat Gile, sir.
To introduce Professor Charudatta Belesar is distinguished academician and researcher in the field of the mathematics, currently serving as an associate professor at Sri Shivaji College, Parbhani, with more than 2 decades of teaching. To the undergraduate and postgraduate level, he has made significant contribution to higher education and mathematical research. Sir earned his PhD in mathematics from SRT University Nanded with research focused on generalization of mapping and fixed point theorem in metric and dimetric spaces. He has impressive research profile with a 25 plus research paper published in reputed UGC listed Scopus Web of Sciences and 4 journals covering areas such as fixed point theory, mathematical modeling, applied mathematics, interdisciplinary research, and computational approaches. He has also prolific author, having written 11 international level textbooks in core mathematical subjects, including number of theory, linear algebra, graph theory, operation research, statistics, rate analysis, and R programming. In addition, he has contributed several book chapters and actively participated in national and international conferences as a speaker, chairperson, and resource person. Dr. Bele sir has received numerous prestigious awards, including the Best Teacher Award, Rashtriya Shikshan Chhatra Award, and Outstanding Academic Achievement Award, recognizing his excellence teaching and research work. Beyond academics, through the passion, design, innovation, curriculum development under NEP 2020, and research supervision at the doctoral level, with a deep commitment to education, research, and innovation. Sir continue to inspire students and scholars through his dedication to the mathematics and its application across the disciplines. Please give a warm welcome to Dr. Vele sir.
Sir,
Sir,
thank you so much, ma'am. Now, I will request to the honorable resource person of today's program, Professor Dr. Vele sir, to share his knowledge with us about the topic Srinivasan Ramanujan, an extraordinary mathematical journey.
Thank you. Good morning, everyone. Am I audible?
Yes, sir.
Yes. Let me thank the organization of this national seminar on Indian mathematician and their contribution by Yashwantrao Chauhan College, Ambejogai, and specially respected principal Dr. Sridas uh, Sirsat sir for inviting me for this seminar. And I am happy to be part of this program conducted by this prestigious institute. Now, let's come to my talk, Srinivas Ramanujan, an extraordinary journey. Now I share my screen here, first of all. Yes. Srinivas Ramanujan was one of the Indian greatest mathematical genius. He made substantial contribution and great research was into the analytical theory of number and work on elliptic function. 1 minute. 1 minute. So this is from the family record of Srinivas Ramanujan. I'm audible?
Yes,
Hello?
sir. Yes, sir.
Yes, yes. Okay, okay. The great mathematician Ramanujan was born in his grandmother's home in Erode, which is a small village about 400 kilometers southwest of Madras. Srinivas was born on 22nd December 1887. He was the first son among the three sons. So this is the family record of Srinivas Ramanujan. This is the photo of Ramanuja's mother, Komal Thalmal. Unfortunately, a photo of his father is not available anywhere. This is a home of Ramanujan in Koikunum, a home window, and Ramanujan's favorite pastime was sit to behind the window in his home and do all school related work there. Ramanujan's father, K. Srivanasa Iyer, was an accountant to a cloth merchant in Kumbakonam on a modest salary. Primary education. When Ramanujan was nearly 5 years old, he entered the primary school in Kumbakonam, although he would attend several different primary schools before entering the town high school in Kumbakonam in January 1898. At the town high school, Ramanujan was to do well in all school subjects and showed himself an able all-round scholar. He stood first in the Tanjore district primary examination. He passed the matriculation examination in 1904. Ramanujan was shown how to solve cubic equation in 1902 and he went on to first his own method to solve the quadratic. It was in the town high school that Ramanujan come across a mathematical book by G.S. Carr called Synopsis of Elementary Result in Pure Mathematics. This book, with its very conscious style, allowed Ramanujan to teach himself mathematics. The book contained theorems, formulas, and short proofs. It also contained an index to paper on pure mathematics, which had been published in European Journal of Society during the first half of 19th century. His biography tells some curious story of his early year. For example, that soon after he had begun the study of trigonometry, he discovered for himself Euler's theorem for the sine and cosine and was very disappointed when he found later, apparently from the second volume of Lonely's trigonometry, that they have were known already. During the school day, he impressed the classmates, senior students, and teachers with his extraordinary institution and astounding performance in several branches of mathematics, which arithmetic, algebra, geometry, number theory, and trigonometry. In latter year, a friend of his recounted the following incident. In an arithmetic class on division, the teacher said that if 3 bananas were given to 3 boys, each boy would get a banana. The teacher generalized this idea. Ramanujan is said to have asked, Sir, if no banana is distributed to no student, will everyone still get a banana? Ramanujan used to ask about the value of 0 divided by 0 and then answer that value cannot be determined. Now, formal education and scholarship. Ramanujan passed matriculation examination in 1904 and joined Government Art College in Kumbakonam. As a result of his success in competitive exam in mathematics and English composition, he secured the Junior Subramaniam Scholarship. In the first examination in art class, Ramanujan had to study English, Sanskrit, mathematics, phys- uh, physiology, and history of Roman and Greece, partly due to preoccupation with researchers into mathematics. He neglected the study of other subjects. He went to his mathematics lecture with number of original and very ingenious result in finite and infinite series. Professor P.V. Seshu Iyer exhausted him but advised him not to neglect the study of other subjects. Unfortunately, he did not pass in English and hence he was not promoted to the senior FA class in January 1905. He lost his scholarship. Ramanujan's failure to get promoted to the senior first examination in art class marked the beginning of a very trying period in his life. In 1906, he set out from Kumbakonam for the first time and joined Panchayappa College in Chennai in the first examination of art class again. After about the 3 months, he fell ill and discontinued his studies. However, he appeared privately for first examination in art in 1907. Through he secured a Synchum in mathematics, he fails to secure a pass mark in other subjects. This marked the end of formal education. In the following year, he worked on mathematics, developing his own ideas without any help and without any real idea of then currently a research topic other than provided by Carl's book. Continuing his mathematical work, Ramanujan studies continued fraction divergent series in 1908. An overview of Ramanujan notebook. These are the three Ramanujan notebooks. Ramanujan left 3 notebooks. The first notebook to telling 351 pages contains 16 chapters of losing general organized material with remainder unorganized. In the organized part, which ended on page 263, in the pagination of Ramanujan wrote on only one side of the paper. Shortly thereafter, Ramanujan began to write on both sides of the page and then returned to the unused reverse side of recorded additional material, so that only about 20 of the 351 pages are actually blank. The second book is revised enlargement of the first and was probable compassed during the 9 months of Ramanujan held a scholarship at University of Madras prior to his departure for England. This notebook contained 21 chapters compressing 256 pages, followed by 100 pages of miscellaneous material. The short third book contained 33 pages of unorganized entries. Hardly established that the notebook contained approximately 3,000 to 4,000 results. This estimate appears to be correct in Ramanujan notebook part 1 to 5, counted 3,254 results. Through emphasize that different people will telling such a counting in different ways. Each chapter contained approximately 50 to 150 entries. Hardly also estimated that two-thirds of Ramanujan work in India was rediscovery. The notebook contained almost no proof. Perhaps there are about 10 to 20 results for which Ramanujan sketches a proof, often with only one sentence. Several topics examined by Ramanujan in this notebook. Start with elementary mathematics. Here, I take only outline of content and some important formulae, not in detail, because it is very vast and cannot possibly explain in few lectures. So taking only point and important formulae from this notebook, number theory, then the gamma function, Q series, theta function, continuum fraction. It is remarkable fact that hundreds of papers have been inspired by Ramanujan entries in his notebook and his collected papers. Now Ramanujan lost notebook. In the spring in 1976, George Andrew visited Trinity College, Cambridge to examine the paper left by Watson. Among Watson's paper, he found a manuscript containing 138 pages in handwritten of Ramanujan. It is natural to call the newly found manuscript Ramanujan's lost notebook. Now the question is, how did this manuscript reach Trinity College? After Ramanujan died in 1920, G. H. Hardy strongly urged that Ramanujan's published paper, notebooks, and other unpublished work be collected together for publication. A handwritten copy of Ramanujan notebooks was shipped from University of Madras to Hardy in 1923, and at the same time, other manuscript and paper of Ramanujan were also sent. These apparently is no record for precisely what was included in this shipment. Thus, most likely, the lost notebook was sent to Hardy in 1923. In 1920 and 1930s, Watson wrote almost 40 papers on the work of Ramanujan, most of which arising from either Ramanujan's letter to Hardy or from Ramanujan's notebook. In particular, he wrote Ramanujan's mock theta function, which Ramanujan discovered in the last year of his life and described in a letter to Hardy only about 3 months before he died. Thus, probably some time after Watson's interested in Ramanujan's work went in the late 1930, but before his death in 1947, Hardy passed Ramanujan's manuscript to Watson. Since many identity involving mock theta function appear in the lost notebook, it is certain that the lost notebook arises from the late year of Ramanujan's life. About 60% of approximately 630 claim made by Ramanujan in his lost notebook pertain to mock theta function and other Q series. Most of these results have been proved by Andrews. The remaining 40% is devoting mostly to topic examined by Ramanujan in the ordinary notebook. For example, theta function, identity, modular equation, Einstein series, integrals of theta function, incomplete elliptic integrals of the first kind, progress Ramanujan continuum fraction, and other continuum fraction are some of the topics found in the lost notebook. Ramanujan published paper made a volume of nearly 400 pages, but he also left a mass of unpublished work which has been never been analyzed properly until the last few years. For his mathematical ability and natural genius, he has been compared with all-time great mathematician Euler, Gauss, Jacobi. He left about 4,000 original theorem, which is a great contribution in the work of research in mathematics. So these are the some references. Thank you.
Thank you, sir. So, thank you so much, sir, for valuable information regarding the topic. It will be very helpful for us. Thank you once again, sir. Now I would like to call Nagargoji Madam for vote of thanks.
And appreciate our principal, Dr. Shudha Siddharth sir, and always encouraging and directing us. And I would like to thank our vice principal, Dr. Ramesh Shinde sir, and Professor P.K. Jadhav sir. Especially thanks to our technician staff, Ali sir and Asif sir. I also want to thank all of you for joining and helping us to make this day successfully, and especially for all of us. Any event is unsuccessful without a loving and appreciating audience. All people who are attending here deserves a big thank you to all participants and listeners of today's program for your support. Many thanks. Thank you for all of you.